Right, we greet each other this afternoon. We are continuing with the double integral. Now we are looking at another aspect of double integral, considering what we call polar coordinates. Remember, for polar coordinates, we have these coordinates r, theta, as opposed to Cartesian coordinates x, y. So we want to find the relationship between r theta and xy, r theta being the polar coordinates. Remember, we have the relationships as x is equals to r cos theta and y is equals to r sine theta. Then r squared is equals to x squared plus y squared. Okay? And the rectangular region now in polar becomes the coordinates r theta such that a is less than r is less than b, and alpha is less than theta and is less than beta. Now r is the radius, then which is ranging from A to B. Then theta is the angle generated by the radius or by the force as it moves around a circle. So the idea now is to move from the double integral f x y dx dy, like we said, it can be dx dy or dy dx, then into the polar now, which will be alpha, beta, then a, b. Then everything now becomes, instead of x, we put r cos theta, then r sine theta in brackets. Then dA or dx dy becomes, let me just write it here, or becomes r dr d theta. So dx dy or dA in Cartesian transfers to r dr d theta. If you can take any calculus textbook, they will show you how you arrive at that one. And wherever there's x, you put r cos theta, there's y, you put r sine theta. So we are saying dA is nothing but r dr d theta. Okay. So we then want to, the reason why we want to apply the polar coordinates is because sometimes the integrals, they are difficult to handle. If they have x squared, y squared, then square root thereof, they are difficult to handle. So that's why we have to transfer them from Cartesian to polar. So let's look at an example. Look at an example. So if we let, example 4, if we let R be a rectangular region xy such that x squared plus y squared is less than or equals to 4 be a region bounded by a circle, bounded by a circle. So the question is find the double integral. Find the double integral given by r square root of x squared plus y squared dA. Okay. Remember, dA is the same as dx dy. Now let's look at the solution. Now, before we write down the double integral, we have to, from this region here, you'll find this is a circle of radius r. But r is what? Is 4. So it's radius 2. So we can then say x is equals to, instead of r, we put 2 cos theta. Y is equals to sin theta. So, which then means our integral r, instead of square root of x squared plus y squared, we then put square root of r squared. Then r dr d theta. But what is the square root of r squared? Square root of r squared is simply what? R, then times r there. So which is equals to, r is ranging from 0 to 2. Then pi is the whole circle. You see? The circle, so it's from 0 to 2 pi. Then square root of r squared is r times that r. You will now have r squared dr d theta. Okay? Now, we can then integrate this with respect to r. You will have 0 to pi. It will be simply 1 over 3 r cubed from 0 to 2. Then the theta. Then you substitute 2 into r, that's 2 to the power 3, then divided by 3 minus 0 to the power 3 divided by 3. So it will be simply 0 to pi, then 8 over 3 d theta. Okay? Then you integrate this with respect to theta. You will have 8 over 3 times theta, which is 8 theta over 3 from 0 to 2 pi. Then you substitute there, you will get your 8 times 2 pi over 3, which will be your 16 pi over 3. That's your double integral. Okay? That's your double integral. But if we had attempted to solve this one, we were not going to easily solve it manually, except maybe through a computer. So that's why we need to move from Cartesian to polar. Once you transfer everything to polar, you'll find now it becomes a piece of cake, it becomes easier to handle. So in most cases, if you see there is a circle and the integrand is of this form, then it means even if it's not straightforward that you transfer from Cartesian to polar, it means you have to transfer that on your own. Okay? Right, let's wrap this. Look at another example. Example 5. The question is, find the volume bounded by, find the volume of an object or of a solid bounded by z is equals to 4 minus x squared minus y squared, and z is equals to 0. Okay? Find the volume bounded by z is equal to 4 minus x squared minus y squared, and z is equals to 0. Then when z is equals to 0, the region on the plane is the disk or a disk obviously x squared plus y squared is less than or equals to 4. Okay. Now you can also see, it's just coincidence though, you will see that this one is similar to the previous one. Now, but here we don't have the f xy straightforward. We generate it from here. Okay. Now we know that r squared is equals to x squared plus y squared from the polar, and here we have on the plane, the xy plane, z is 0, which means we have got this here. When z is 0, we have this disk. Okay? So which then means our x is equals to r cos theta as previously, then y is equals to r sine theta. Okay? So the double integral now, we are going to integrate will be simply here. Instead of this, we put that. Okay? So it will be simply r squared, then times our usual r, the theta. Okay? Then r is ranging from 0 to 2, then theta from 0 to 2 pi. Okay. Then obviously this will be 0 to 2 pi of